All right, welcome to lesson 5.14. This is the last lesson in Unit 5, and so we're going to be taking a look at some more complex real-world situations that can be modeled exponentially, and we're going to utilize logarithmic functions to solve some equations that arise from those situations. Before we take a look at a couple of problems, we want to make sure that we understand a couple of steps that will make sure we're successful to the best of our ability here. So when we're tackling a real-world problem, you want to make sure that you identify the input and output variable. In most situations, right, the input variable is going to be some sort of time. So you might think of this usually be represented by t, but that doesn't have to be the case. That's usually going to be the input variable or the independent variable, and the output variable can be some amount of something, or distance traveled or something like that. And so when you identify the output variable, you want to give it a name that is corresponding to what type of whatever it is. If it's an amount of something, I like to use A, but you don't have to. And so once you've identified those two variables, the independent and dependent variable, you want to go ahead and identify any other given information that is going to help you understand the situation. The rate at which it's growing, how many of something there are at the beginning, so on and so forth. You then want to go ahead and identify what you're trying to find and represent this algebraically if possible. So I will interject here, and before you get into answering the questions, if you don't have a function given to you, you want to build a function that models the situation before you start answering any questions. So before you identify what you are trying to find, you should make sure that you have a function that models the situation. Once you do, you can identify for each part of the question, or if there's only one part, what it is that you're trying to find, and you want to represent this algebraically if possible. What I mean by that is, let's say that you're trying to find when something happens. You want to identify that you are trying to solve for t. Writing it out like that helps you to put together a plan for what you're going to do. And of course, combining that with the given information, you can then come up with a plan for finding that particular value. All right, so with that being said, let's go ahead and take a look at a couple of problems. Okay, here's the first one. Go ahead and copy this down and go through the steps that we just discussed on your own first. We'll take a look at this one a little bit more in depth together, and then I will give you one more problem to do more on your own. All right, hopefully that went well. I'm going to first go through and read the problem and identify the input and output variables. So the input variable is t, that's representing years. The output variable is p, and this is the amount of money or the worth of your investment. A couple of key pieces of information here. I start with $500 and I'm getting 10% annual interest rate. So the rate they're using is 10% per year. They're also compounding it 4 times per year, which I can see in the equation, right? I'm getting that 10% split up into 4 pieces and compounding that 4 times each year. After that, I go into reading the question, and I can determine very, very quickly that what I'm looking for, what I'm trying to find, is the number of years, or in other words, a value of t, when the total amount will reach $1,200, which means that a of t, the amount, must be equal to 1,200. So there I'm given the equation that I can use. This is a function of t, so I can solve this equation for t and find the value I'm looking for. All right, so hopefully that got you on the right track. You want to make sure that your work is clean. You want someone that's looking at your work to be able to see your thought process as you go through. So it should be very clear what exactly you are doing with each step. And then your final answer should be verified. So check your answer using any number of methods. You could even graph the functions, and check the intersection point if you'd like, and then make sure that you've written your answer out in a full and complete sentence. All right, once you have, go ahead and press play again, and we'll take a look at one more question. All right, so here we're dealing with more bacteria. We have a population of bacteria that is growing according to this model here. And there are two questions. So you want to make sure that you've annotated the question fully, you understand all the pieces, go back and make sure that you followed through each of those steps that we discussed. And then make sure you're checking your answer, both just doing a check for reasonableness, right? Does the answer that I got make sense given the situation? And also a check for that it is correct. So going back and checking using the function, and then writing your answer out in a full and complete sentence. Make sure you've done so that we can take a look at your finished and complete work.